Namaskar, good morning everyone. My name is Sudhanshu Pandey. I am your maths educator. Today I am going to teach you mathematics from the very basics for grade 6, and today I will start with the number system and then we will move on to the divisibility rule of 2 and 3. Okay, today we will learn the divisibility rule of 2 and 3, but before that I would like to start with the number system. So first of all, students, what is a number system? So if I talk about the number system is a group of numbers. In the number system, we have a group of numbers. On the basis of the kind of numbers, the group are named differently. Okay, so first of all, the first number system that we have to learn is, and you might all be knowing it. So I am starting, so this video is basically for the person who are in grade 6, who are in grade 7, who are in grade 8, and might be who are in grade 9 as well, because basics is a basic for each and everyone. All right, so let's start. So the first kind of number that we should know is natural numbers. And if I ask you, dear, what are natural numbers? So we say the numbers that if I ask a student or a person to start counting, so what he will do? He will start counting from 1, 2, 3, 4 like that. All right. So if a person is starting counting from 1, so such numbers 1, 2, 3, 4, 5, and these are endless numbers. These are endless numbers and it will go up to infinity. Please remember, this is a symbol of infinity. If I ask you, what could be the largest number in the world? You will never be able to tell me. Why? Because for every number, there is a successor. What is a successor? So successor means plus 1. If I say, what is a successor of 100? So you will say, it is 101. So that means the largest number can never exist. Whatever number you will say to me, I will just add 1 to it and made a successor of that number, and I will say that next number is bigger than the previous number. So that's why I can't write the largest number in the world. So for that purpose, I have used this symbol infinity. It is not a number, it is just a symbol. All right. Now these natural numbers are written as a group. It has a name, so there is a symbol for them as well. So we write n. So wherever you will see n, capital N in mathematics, you must see it as a natural numbers. They are the natural numbers. Then dear, we will move on to the next kind of number, which are known as whole numbers. And if I ask you, what are whole numbers? What is the difference between a whole number and a natural number, dear? So whole numbers, first of all, they are represented by capital W. And the starting of this number is from 0, 1, 2, 3, 4, and it goes on up to infinity. The only difference between a natural number and a whole number is 0. 0 is there in the whole number but not in the natural number. If you ask a person to start counting naturally, he will start with 1, 2, 3, 4. He will not say 1, 1.5, 2, 2.5. So that's why those numbers are known as natural numbers. And without 0, this group is not completed. So when this 0 is included, we say that these are whole numbers. These numbers are whole numbers. Coming to the next number system. So if I add negative numbers to the number line, if I also add the negative numbers to the number line, then such numbers are known as integers. We will come to each kind of number system in detail, but today in our class we will just learn the kind of number system and the divisibility rule of 2 and 3. Now what are integers? So integers are also, if you have a positive numbers 1, 2, 3 up to infinity. If you include the negative number as well, then together all of these numbers from negative infinity to negative 3, negative 2, negative 1, in between 0, 1, 2, 3 and it goes up to infinity. These set of numbers with positive, negative including 0 are known as integers. And they are represented by the letter Z. Nowadays they are saying Z. In our time we were used to say it Z. Z means zebra. Now coming to the next kind of number system. Such numbers are known as rational numbers. The bigger system of this are rational numbers. So you might be knowing or not knowing, they are represented by the symbol Q. And if this is a number line, the center part is 0 and then you have 1, 2, 3, 4 and then on the left side you have negative 1, negative 2, negative 3. Do you really think that all numbers are represented here? The answer is no. Why? Because there are also infinite numbers between 0 and 1. There are also infinite numbers between 1 and 2, and such numbers can be considered as fractions. And there is one more kind of number which are irrational numbers, which we will learn in grade 9. But right now we will stick our knowledge up to rational numbers. So rational numbers are the numbers which can be written in the form of P by Q. Now you might be thinking, what is P by Q? So P is also a number. Sometimes in mathematics we use alphabet to represent a number. So dear, P by Q is also numbers, but P is known as numerator and Q is known as denominator. So the definition of a rational number is, we will say, a number which can be written in the form of P by Q are known as, P by Q where P comma Q belongs to Z. Now this is a symbol for belongs to. This is a symbol for belongs to. This is a symbol for does not belong to. Sometimes you use this symbol for equality sign. Sometimes you use this symbol for not equal to. So likewise we use this symbol. We will say that P and Q belongs to Z, means P and Q must be an integer, and there is one more condition, Q must not be equal to 0, are known as rational numbers, are known as rational numbers. So basically first we have to learn that there are 4 kind of number system. Till now for the grade 6 to 8, the first kind of number system are known as natural numbers, which are represented by the capital letter M. It starts from 1, keeps on counting 1, 2, 3, 4 up to infinity. Then we have one more number system whose name is whole numbers. The group of numbers whose name is whole numbers are represented by capital W. And then we will the only difference between natural and whole number are 0, and then the integers, in which we include negative number as well, and then we also include the fractions, and those numbers together along with this positive, negative and fractions, we say those numbers are rational numbers. They are represented by the capital letter Q, stands for quotient. Q stands for quotient, and when you divide a number, you will get the division. The answer to the division is a quotient. Okay, I will come to the division part later on, where we will learn there are 4 components in a division: dividend, divisor, quotient and remainder. We will come to that, but right now we will focus on the divisibility rule for 2 and 3. Now what I am going to say you will see a pattern here. If I write the table of 2 into 1 is 2. So right now what I am going to teach you is the divisibility rule. Now you might be thinking, sir, what is a divisibility rule? So divisibility rule is a rule in which we can say that a particular given number can be divided by the given set of numbers just by looking at the number. There are certain rules. You don't need to divide. Just by looking at a certain rule, we can say that these numbers are divisible by a particular set of numbers. So right now we are going to learn for 2. So I am writing the table of 2 up to 10, so that you can see the pattern here. 2 into 4 is dear 8, 2 into 5 is 10, 2 into 6 is going to be 12, 2 into 7 is going to be 14, 2 into 8 is going to be 16, 2 into 9 is going to be 18, 2 into 10 is going to be 20. Now if I ask you, can you see the unit digit of this pattern? The unit digit means I am talking about the digit at the ones place. See, it is 2, 4, 6, 8, 0. I am just talking about the unit digit. Again it is going to be 2, 4, 6, 8 and 0. That means you can see the numbers ending with 0, 2, 4, 6, 8 keep on repeating and they are divisible by 2. So that is the divisibility rule for 2. We say a number is divisible by 2. A number is divisible by 2 if the unit digit is either 0, 2, 4, 6 or 8, and such numbers are known as even numbers. We can also say numbers ending with 1, 3, 5, 7 or 9 are known as odd numbers. All right. Now we are going to learn the divisibility rule for 3. Now what is a divisibility rule for 3? Somebody is online, I don't know. So it might be my first subscriber. Somebody is online, I don't know who is online. Hi. Fine. So next we are going to learn 3 into 1 is equal to 3, 3 into 2 is equal to 6, 3 into 3 is equal to 9, 3 into 4 is equal to 12, 3 into 5 is equal to 15, 3 into 6 is equal to 18, 3 into 7 is equal to 21, 3 into 8 is equal to 24, 3 into 9 is equal to 27, 3 into 10 is equal to 30. And if I ask you, what is the sum of the digits in the final product? Sum of the digits. you must understand what are digits in mathematics. So dear, there are 10 digits in mathematics. They are 0, 1, 2. I am writing all the 10 digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are also the numbers, but they are digits. If I ask you how many alphabets are there in English, we will say, sir, there are 26 alphabets. But if I ask you how many words are there in English, so we'll say, sir, approximately 20,000 to 30,000 or 1 lakh. But they are finite number of words, because a word is a unit which has something meaning. If it doesn't have any meaning, it is not a word. All right. So now if I ask you, a digit is a number, the answer is yes. 9 is also a number, 9 is also a digit. But in English, A is an article, it is also an alphabet, but B is a letter, it is not a word. A can be termed as a word, but B cannot be termed as a word. C cannot be termed as a word, D cannot be termed as a word. So word means it is a meaningful unit. It is a group of letters which has a meaningful unit. But in mathematics, we keep on repeating the numbers and it will form a number. We keep on repeating the digits, it will form a number. So now what is the sum of digits? So if I write 45, what is the sum of digit? It is 4 plus 5, which is 9. If I ask you what is the sum of the digit here, you will say, sir, it is 7 plus 8, 15. I say no, don't say 15, just keep the digit up to one digit. So 5 plus 1 is how much? 5 plus 1 is 6. So ultimately we will say, we will just try to find out the sum of the digits here. So the sum of the digits for 3 is going to be 3. For 6 it is going to be 6. For 9 it is going to be 9. For 12 it is going to be 1 plus 2, which is again 3. For 15 it is going to be 1 plus 5, again 6. For 18 it is going to be 1 plus 8, again, which is 9. For 21 it is going to be 2 plus 1, which is 3. For 24 it is going to be 2 plus 4, 6. Then we will have 2 plus 7, 9. Then we will have 3 plus 0, 3. And it keeps on going like this. That means you will see the pattern of 3, 6 and 9, 3, 6 and 9. So we will say, if the sum of all the digits is either 3, 6 or 9, the number is divisible by 3. And one more technique that I use here is, we don't need to add those numbers which already have 3, 6 and 9 in them. So sometimes the students are given the number like this, 1, 2, 3, 4, 5, 7, 8. And they've been asked, is this number divisible by 3? So they keep on adding 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5, 15 plus 7, 22 plus 8, 30. No need to do like that. So the numbers whose addition form 3, 4 plus 5 is 9, 7 plus 8 is 15, 5 plus 1 is 6. So you say 3, 3, 9 and 6. All numbers are divisible by 3. You don't need to add the numbers. You just need to look for 3, 6 and 9. That's it. Keep on ignoring those numbers. Just add the other numbers. And again, after adding, just try to see if they make 3, 6 and 9. Just ignore them and just add the other numbers. So in this way, we get the rule of 3, that if the sum of all the digits is either 3, 6 or 9, the number is divisible by 3. So I will write it, and with this I am going to end this class. So we will write for the divisibility rule for 3. A number is divisible by 3. A number is divisible by 3 if the sum of all the digits as a single digit is, as a single digit means if it is 15, you don't say 15, just say 6. Again add them. As a single digit is 3, 6 or 9. So with this, again namaskaram, pranam, and I want to end this class now. I hope that you got some meaningful knowledge from my class. Signing off from my side, Jai Hind, Jai Bharat, Sudhanshu Pandey. Bye. Please take care. Bye.